Welcome to another episode of Code for Thought. Now, when was the last time you read through a license agreement? What license does your software have? Does it have any? And how does this relate to how open science in our software is? Teresa Gomez-Diaz from the Université Gustave Eiffel in the east of Paris thinks we should pay a lot more attention to these questions. For a number of years, she's been working with others to promote open science, which in her view also includes open and free software. In my conversation with Teresa, we touch on questions what open science is, does or should include, what kind of licenses are available for software, and what countries and organizations like Unesco are doing about it. And being a good citizen, Code for Thought will add its own creative license to episodes, which you will find in the metadata. And here now my conversation with Teresa.
Thank you very much, Teresa, for seeing me today. This is very exciting because this is not only a very interesting subject we're going to talk about, it is also the first face-to-face interview that I will conduct after the beginning of the pandemic. This is really completely new. And before we start talking about open science and your work, could you perhaps introduce yourself?
Hello, Peter. Thank you very much for coming here and for this interview. I am Teresa Gomez-Diaz. I'm Spanish. I work in France since more than 20 years. I am a research engineer here, a CNRS research engineer. CNRS is the National Center for Research. Mm-hmm. I came here in 2002. Since 2006, I am working in research software dissemination, and all the subjects around this subject.
Well, thank you very much. You live here for a long time then.
Yes.
So. And I believe you've been working on the subject for a very long time. You mentioned 2006.
Yes, but at the time, no one spoke about open science. When I first started to work on research software and all the questions of dissemination, open access, etc. And then I started to work in a European committee, and they were related to open access. So this is when I started to see much larger subject. My first step was free software and open source software. Then I started to understand open access for publications and open data. This work we are talking today about is a long time of observation of many things.
Okay. Well, because the subject is open science today, and there seems to be no clear definition of what it is. So why is it so difficult?
I showed you this image of the mushroom of Eva Mendez. That is working for a long time in European committees of open science. And as you can see, it's a very complex landscape because there are many different components. For example, the first one is open access, but then people started to talk about open data, and then open source software, open research, what this means, open methodologies, research integrity, research infrastructures. So there are many, many components. And it's very complex, very complete vision, but difficult for people that has a first view of this. Is very complicated.
I think the metaphor of a mushroom sounds actually quite appropriate. There's what you see on the surface, but then there's a lot going on underground, and that seems to be the case here. So what do you specialize in specifically?
My first specialty is open source software, free open source software. This is the first step. And then I started to be interested in open access for publications, for scientific publications. I know less about open data.
Well, thank you very much for this overview of open science. It is hard to agree on a common definition, is it not?
It is, and it is not. It is because, as you see, it's a complex landscape, and many people have many different views. But there is ongoing work in the UNESCO at international level. It has been asked in the committee of 193 countries, member states, and they asked at the end of 2019 some work about open science, and the UNESCO has provided a recommendation that has been approved last November. And so it sets a definition.
Ah, okay. What is the definition?
It's complex.
You probably have to read that out then.
It takes several lines. It's a big document of 30 pages, I think. But it's important because it's very recent work, but this will drive that many countries adopt this vision and many scientific communities adopt this vision. At the moment, it's difficult, but in few years, it will be a more universal view and more accepted view.
So what makes it so difficult to get to that unified version?
Because there are many things. People, for example, says open science is open access to publications, open source software, and open peer review. Others says collaborative work and citizen science.
Oh, okay.
So many people speak in many different ways about different components, and they put different components. And when you try to get the whole view, it's difficult. The scientists that hear about open science, one day hear one thing, and on the other day they hear other thing. So what is it?
Indeed, exactly. I believe that you gave a presentation last year, did you not, about the future of open science?
I did a poster presentation in the AGI virtual conference in October last year. And in fact, I presented a work in collaboration with Tomás Recio, who is a professor at the University Antonio de Nebrija in Madrid. And in fact, he was my former professor, so it's very funny to work with him. Very interesting as well, because he's magister professor. I don't know how do you say. He's retired, but he's still working.
Emeritus, I think it's called.
He's working a lot, more than ever. But he has a view of science in a very international way. In many different areas related to mathematics. So he's very interested to work with him because he puts a lot of vision in this work. So in fact, in the poster presentation, we present this work, this article, towards an open science definition as a political and legal framework on the sharing and dissemination of research outputs. In this poster, it simplifies and structures the information. We have selected some parts, so we have given a definition in 2 lines.
Okay, but we're going to see that, or we're going to hear that in a minute.
You like it. So open science, in our view, is the definition that we propose, is the political and legal framework where research outputs are shared and disseminated in order to be rendered visible, accessible, and reusable.
Which is sort of summarizing the 30 pages document from Unesco that you talked about earlier.
I think it could be seen this way.
Okay.
But I don't know if everyone will agree with you.
Okay.
For this definition, we have select 3 movements.
Okay.
The open access, the first one is the publications, because the publications is the main tool for scientific communication. So it's the most important object, scientific output. And the Budapest Open Access Initiative of 2002 has defined what means open access to publications, to scientific output. So this is for us the first pillar to support our vision. The second one is our choice. It's not the choice of everyone, but it's our choice to put the second pillar in the free software definition. That was given by Richard Stallman and the Free Software Foundation around 1985. So in fact, the Budapest Open Access Initiative was inspired by what was happening in the software movements. This definition is very important because it expresses for liberties, for the use of the software, the liberty to the freedom. Sorry, it's the freedom.
Liberty works too.
But they speak about freedom, so
Okay,
we should keep the right word. So the freedom to use the software, the freedom to study it and to be able to modify it, the freedom to redistribute copies of the software, and the freedom of redistribute your modifications of the initial software. That is very important because they say that everyone could use the software. And this is what we are looking for in science, that everyone has access to scientific information. So for us, it's very important, this definition. Also because how do you know that a software is free? It's because there is a license. The license, which is a legal document, you can verify that you have these freedoms. And the third step to support this vision is the work on the Committee on Data for Science and Technology. That means CODATA is the name. And it's a very old organization, international organization that speaks about data for a long time. The first time I started to look information about this committee, I saw all newsletters, and the vocabulary is really actual. They speak about evaluation, they speak about reuse, they speak about many things, dissemination. Each of these three steps or movements, they represent three different complex worlds. Each one is independent of the other. Each of these worlds has its own interest, economic interest. There is a lot of money in the publications market. There is a lot of money in the software market. There is a lot of money in the data market. This adds complexity to all this work.
Okay, I think sort of to summarize, so there are the three pillars, sort of the Budapest Open Access Initiative that deals with the publication, and then there's the free software, which I find quite interesting. And then the third pillar is the data and data management, data sciences and data technology. What made you select particularly any of those? Like, for instance, why did you choose the Budapest Open Access Forum? Or why did you choose the Free Software Foundation?
The main communication tool in scientific world is publications, is articles published in journals. The world of publication was closed, and so it was very difficult to access to some article. If you were not, for example, in a university that were paying, the library was paying a lot of money to have some journals. The open access definition to publications is very important to say that everyone should access this information. And the free software definition is a vision. For publications, what is important is that you are able to read it. For software, it's important that you might use it. For data, it's the same. This is very political view. The governments are working on open data to make data available to everyone. And this is not easy to understand, that data produced in the scientific world is part of this political vision. And it's not easy to open publications, to open software, or to open data. But the COVID pandemic has shown the importance of access, fast, quick access to all this scientific information. For example, even journals that were not open, they did publications for COVID will be open. In not only publications, but the data associated to the publications. And the data is manipulated with software. And software sometimes is commercial, but sometimes is the software done in the laboratories like this one. To have the data is no use if you don't have the software.
And I think you're touching on a number of interesting points because, as you said quite rightly, there's a lot of commercial interest in all of these aspects. I used to work for a scientific publisher at Elsevier.
Very well now.
So I know they make a lot of money through that. And also software companies. I mean, sort of these are the most powerful companies in the world these days. Let's focus a little bit on the software aspect, because I think you also do a lot of work on licensing and software licensing and emphasizing the importance of using licenses. How can we make software more open in form of licenses, and why is it important that we pay attention to licenses?
Okay, very good question and very important one. In fact, when I started, the director of my laboratory came to see me and said, in this laboratory we do software, but we don't know anything about. Would you like to take care about this? I said yes. And in fact, it was very interesting, and it has been my main work since then. I have a mission. So the mission speaks about the visibility of the software produced in this laboratory.
Okay.
So I started to work first alone, and then I integrated a national project that had two different goals, and one of them was the same as my mission, to render research software produced in the laboratories more visible. And then when you start to work on this, you say, it's important that this software has a license because it will be visible. If you render this work visible, it's because other people would like to use it. And if there is no license, what happens? So, in fact, as I told you, the importance of the free software definition also shows the importance of the license, because a software is not free if there is no a license that says so.
That's a quite important aspect, is it not?
Yes.
So what happens then with software that has no license?
So, in fact, it's a legal question. If you use the software without the right to use it, you are not legally okay. How do you say this?
You're not supposed to use the software if it's not licensed.
One thing is the technical thing. You can use it, but legally speaking, you cannot use it if you don't have a document that says that you can use it. In fact, the license states the sharing conditions. So if you are going to give a software away, it's better to say in which conditions you give this software to other people. They can use it, they can modify it, they can reproduce or give copies or not. So this is the license role. If you don't have this right, in fact, you cannot integrate the software in another software. And as you say, in my home, in my kitchen, I can do the recipes. There is no problem. But when you like to give the software away, you may have problems if you integrated software that has not the right license.
So what happens that I'm taking somebody else's software and I have the license for doing that, but something goes wrong. Who is responsible then? Okay,
so this is also a question, and this is also the role of the license. Usually, all the license in the world, private or no private companies, usually they have a statement that says, I am not responsible.
Okay.
You can imagine that if your software is using a plane and the plane crashes, you don't like to have any responsibility.
No, not really.
This is also important. And in fact, people think that this is a problem with free software licenses. But if you look for the text of license of Microsoft, they also have this kind of... I don't remember, because this is work I have done a long time ago, but I have read one Microsoft license once. So they take care.
I mean, the problem is that as software engineers, we usually don't read licenses at all, and we don't usually care about it. So how would you think that we convince them to actually pay more attention to it?
The question also that we are working in a scientific world. companies, for example, when they sell a software, they take care of someone else is using or not the software, etc. In scientific world, we don't care a lot about these questions. But it's also important because sometimes people have given the software and it's used in a way that you didn't expect and you don't like. So to have a license says that I give the software in these conditions. Then you don't care anymore about how people will use it or not. There are many licenses, but they can be classified in 2 or 3 sections. This is the classification in strong copyleft. Examples are the new GPL license of the Free Software Foundation.
The new GPL one,
The weak copyleft, in fact, and no copyleft at all. And people now have a more simplified vision in 2 sections. No copyleft or copyleft.
What does that mean, no copyleft and copyleft?
So that means if you have a license like a new GPL in your software, you are saying, okay, I give you the software, you can use it, you can do a lot of things. But if you disseminate again this software or the modifications you have done to this software, you should give the same license as I gave before. This is the condition. I give you the software, but I don't like that you put the software in a private context.
It's a very strong binding. So the new GPL license basically forces you that anybody who is using software that uses that license needs also adhere to the GPL, to the new GPL license for any further development of that software.
Not for the developments. In your kitchen, you can do whatever you like. But if you like to give the new product, you should give it in the same conditions as I gave you the first one. And no copyleft. That means that you give the software, but everyone can do whatever they like. They can do even private software.
I think there are typically, when you go to standard source code repositories like GitHub, for instance, you can select nowadays, you create a new repository, you can create a license with it, and they give you a choice. So we already talked about the GNU GPL license. So the weak one, what would be an example of that?
Examples are BSD or MIT license. The question is that when first you attack this question of license, it is also a complex word. As I said, there are many licenses. But once you understand this classification and which are the examples that corresponds to each category, it's easier to choose. Because, in fact, you are giving your vision, what I would like to accept. This is very important because you can be disappointed if you don't set the right setting.
And I think it also plays into the potential success of a software. So, for instance, I know that the GPL license is very strict, right? And so people are quite hesitant to use that. Certainly companies are. If they sell or distribute the software, then they're bound by the same license using the new GPL.
But they have a benefit. They have a lot of benefit of using this software. To be able to watch the code, the source code, is a very big benefit. And there is a little tax to pay. Companies cannot ask for everything without paying anything because they are making a lot of profit. So this is the tax you should pay is to put the same license to the new output, to the new software. I started many times my presentations with the free software definition that was given by Richard Stallman, his Free Software Foundation, in 1985. And it was a big movement in the software world. But the word free, as you know in English, is not clear. It's free beer. You should not pay for it. What this means free. Also, the movement of Richard Stallman is very radical.
In what way radical?
this is the only way. Everything else is wrong. I agree somehow with some part. But it was a problem for people doing software in companies. They started a new movement called the Open Source Initiative. And it's a movement a bit later, 1998. They gave this definition of open source software. And it's a very complex definition. Okay. And I have been in many, many conferences speaking about software, open source software, and no one has ever explained this definition. I will not do it.
I was about to ask.
In fact, what's the question? Some people don't care about this free software vision or open source software vision. The license that make one software free or open source are the same. So in fact, from some practical point of view, there is no difference. If you don't like to care about this philosophy, there is no problem. You put a license in your software and you give it away, and that's all. So license, there are very little examples of one license that make a software open source software and no free software. You can say open source software is the same as free software. No, because they correspond to very different visions.
Okay.
And the Free Software Foundation is speaking about freedom a lot. The word freedom doesn't exist in the open source software. Or at least I didn't see it. From some points of view, it's very different thing, and in other point of view, is the same thing. Because you are using the same license.
The legal framework may be the same, but it's the way that you use it.
In fact, the license was done some time ago, and then there was some kind of use of software that people didn't think about. So, for example, you have a telephone or a television or a tablet. They have free software. They work with free open source software. But you cannot modify it. You cannot take the software, modify it, and put the software in your tablet in order the tablet works like you like. This is called digital rights management, and the Free Software Foundation is against, obviously. So they need to make the license evolve to take care of this question.
You're giving a course, actually, here at the Université Gustave Eiffel in Paris. So what is this course about? Because you talk about licensing then, don't you?
Yes. So the course is called, I say in French.
I say it in French.
I say in French. Les logiciels de la recherche et leur licence, 3 visions sur un objet. So that means research software and their licensing, 3 visions over one object. Because as you see, there is a complex object where there is the license and there is the software. In fact, the first vision is the philosophy, what means open source software, free software, the community that is behind the software, and what means fork, why you should do a fork or not. Fork means the split of the software or the split of the community.
I think we need to talk about that in a little bit.
Then the second part is all these legal questions, because when you start to speak about dissemination in this world where no one cares about all this, you start to say, you need a license. And then who gives the license? And in fact, it's very complicated question. Because this is the law. You cannot do whatever you like. If you are an employee by CNRS, it's the CNRS that decides your license. It's not you. When you start to understand a bit more about licensing, and then you start to touch the legal questions. And at some point I say, stop. I don't understand anything. Because in our scientific careers, no one speaks about author rights. So I did stop everything and went and follow a lot of presentations of legal issues. I took 3 years I say, I understand, and I did understand. So I am able to present very simple vision of the legal issues.
Coming back to fork, because fork is something that people use on GitHub or Git in general quite a lot. So what happens to the license when I fork my repository?
In fact, the license says that someone can do the fork. What means a fork? A fork it means that you have some software and you take it and do a new evolution of this software.
Yeah.
And there might be different reasons to do this fork. The license that allows to do this.
I understand that part, so that the license allows you to do the fork, but after you've forked, what then happens to the license? So does the license then carry on, or do you need to have a different license for your fork?
This is the copyleft.
Okay.
If the license is copyleft, you need to keep the same license. If no, you can put whatever you like.
I think we're coming to an end of the recording now.
Okay.
But before we close, I think let's talk a little bit about open science and the legal framework that exists. Because where are we with the legal framework today?
For example, in France, there's a law, a recent law in 2016. They call it the Loi de la République numérique. It says things for publications, for documents, and for data. It says that, for example, for publications, if your work is funded by public money, at least more than a half, you have the right to give it in some repository, even if you have signed an agreement with a publisher. It's important to see the consequences of the Budapest Open Access Initiative that has arrived to the law in one country. And the Budapest Open Access Initiative has also a lot of influence in the European Commission vision for science. Things are evolving. They are evolving in a political way and in a legal way. At every level, in country level, in European level, the Unesco work will be very important.
I would imagine that the scientific publishers will not be very happy about this. How do you get them on board? Because they don't want to give up making money, of course, and they put a lot of work in there, to be frank.
It's difficult. It's difficult. As we said, there is a lot of money interest. How do you say?
Commercial interest.
Commercial interest. Obviously, big publishers have done a lot of money for a long time, and they don't like to change it. When the Budapest Open Access Initiative appeared in the scientific world, the publishers were really scared. The question is that they have a lot of money, they have the best lawyers, they worked a lot to confuse everybody.
Okay.
So at some point, no one understood very well what means open access, because there was the green way, the gold way. During years, the scientific community has been very confused and is still confused. The big journals, they say, okay, open access is very fine, but I will make money as always.
Indeed.
So I changed the model. The law in France, for example, so as now I have the right, even if I sign agreement with a publisher, even if I do this, I can put the article in one repository and everyone will have access to this document. So in fact, publishers should adapt to this new vision, and in a way that maybe they do a bit less money. Because in the scientific world, we understand that publishing is important and these companies should do benefits, but not so much. We are speaking really about a lot of money that should be used to fund science, not to fund publishers.
That is a very nice ending, Teresa. Thank you so much for your time.
Thank you to you.
I wish you all the best for the future and all the best for open science.
Thank you very much. It was very nice, very interesting.